Space mission planning and logistics encompass a complex array of challenges, each requiring meticulous attention to detail, innovative solutions, and strategic foresight. From the initial conceptualization of a mission to the final touchdown back on Earth, every phase involves intricate processes and considerations to ensure success and safety. One of the primary challenges in space mission planning is the need for precise trajectory and orbit determination. The path a spacecraft takes must be carefully calculated to account for gravitational forces, orbital mechanics, and the influence of celestial bodies. This requires sophisticated mathematical models and simulations to predict and plan the spacecraft's journey accurately. For interplanetary missions, this involves complex maneuvers such as gravity assists, which use the gravitational pull of planets to alter the spacecraft's trajectory and speed without using additional fuel. The design and development of the spacecraft itself present another significant challenge. It must be engineered to withstand the harsh conditions of space, including extreme temperatures, vacuum pressure, and cosmic radiation. The selection of materials, the design of propulsion systems, and the integration of scientific instruments all require cutting-edge technology and innovation. Additionally, the spacecraft must be equipped with reliable communication systems to maintain contact with mission control on Earth, transmit data, and receive commands, which becomes increasingly challenging the farther the spacecraft travels from Earth. Life support systems are a critical aspect of manned missions, requiring careful planning and redundancy to ensure the health and safety of astronauts. These systems must provide breathable air, drinkable water, and adequate food supplies, along with waste disposal and temperature regulation. The closed-loop systems needed for long-duration missions, such as those to Mars, pose additional challenges in recycling and conserving resources. The launch window is a critical factor in space mission planning, particularly for missions to other planets. These windows are determined by the relative positions of celestial bodies and can be quite narrow, sometimes opening for only a few days every few years. Missing a launch window can result in significant delays and increased costs. Another logistical challenge is the development and coordination of ground operations, including launch facilities, tracking stations, and mission control centers. These facilities must be equipped to monitor the spacecraft's health, track its position, and communicate with the crew if it's a manned mission. Coordinating these operations across different time zones and international borders adds another layer of complexity. Risk management is an integral part of space mission planning. Given the high stakes and the unforgiving nature of space, planners must identify potential risks, assess their impacts, and develop contingency plans. This involves not only technical risks but also budgetary and schedule risks. The cost overruns and delays are common in space missions, requiring flexible planning and efficient resource management. Sustainability and environmental considerations are increasingly becoming part of mission planning. This includes the sustainable design of spacecraft to minimize space debris and the consideration of planetary protection protocols to avoid contaminating celestial bodies with Earth life and vice versa. Furthermore, international collaboration and compliance with treaties and regulations add another layer of complexity to mission planning. Space missions often involve partnerships between multiple countries and agencies, requiring coordination and agreement on objectives, technologies, and data sharing. Lastly, the return and recovery operations, especially for manned missions or missions that bring samples back to Earth, require careful planning to ensure the safe re-entry and landing of spacecraft and their precious cargo. In conclusion, space mission planning and logistics involve navigating a labyrinth of technical, logistical, and regulatory challenges. Each mission pushes the boundaries of human knowledge and capabilities, requiring innovative solutions, international collaboration, and meticulous attention to detail to overcome the myriad hurdles that space exploration presents. As we continue to explore the cosmos, the lessons learned from each mission contribute to our collective expertise, making future endeavors even more ambitious and achievable.